This is Daryl with Cisco Hands-On Training. It's the 28th of May 2008. Today we're going to talk about BGP outbound route selection with MEDs. I changed my website, and so I have a new website, www.ciscohandsontraining.com, and I have a new feed, feeds.feedburner.com/Cisco Hands-On Training. Those of you who were subscribed via iTunes should all have automatically updated to the new feed. The old SwitchPod feed is no longer live. I appreciate if, since I have a new website, I'd appreciate if you find this useful. I'd appreciate if you link to my website. And for those of you that were kind enough to put positive feedback in iTunes, in the iTunes directory, I had to recreate the iTunes directory entry, so any of that old positive feedback is now gone. So I'd appreciate if you'd put positive feedback or comments in there again. Okay, let's talk about BGP outbound route selection with MEDs. What we're talking about here is we have two autonomous systems: Autonomous System 65001 at the top, Autonomous System 65002 at the bottom, and for each of the routes that Autonomous System 65002 is sending to 65001, 65001 can choose to send it to the middle router or to the bottom router. And we want to influence how that decision is made. And one way to influence that decision is for Autonomous System 65002 to originate a BGP attribute. It's a well-known optional attribute known as MEDs. Multi Exit Discriminator. In this case, we have multiple exits from 65001, and the Multi Exit Discriminator allows you to helps give internal routing information from the bottom autonomous system to the top autonomous system. What it does is, if you have metrics for the routes inside your if you have metrics for the routes that you're advertising in BGP, if you have metrics for them inside an interior gateway protocol, such as OSPF, it will put those metrics inside the MED attribute and send it to the top router. And then the top router can, or the top autonomous system can use that in its decision-making process. Let's review the BGP decision-making process. The highest priority is wait, which is a Cisco-specific configuration item that's configured locally on a router. Next highest is local preference. That's a well-known optional attribute. 100 is the default local preference. If wait and local preference are the same, then you prefer routes that are originated with this is not worded great. You prefer a route originated with a network statement over a route that is redistributed or aggregated. If that's equal, then you prefer the shortest autonomous system path attribute. And this is really where most of the BGP routing in the internet is done. You basically, by default, pick the shortest path, the shortest number of autonomous systems between you and the destination. You prefer the better origin, which is origin IGP, which is complete, over origin EGP, which EGP is the old exterior gateway protocol, over incomplete routes, which are redistributed. And then, now pretty low in the priority list, you prefer the lowest MED. Remember, a MED is a metric, and a lower metric is better, whereas a local preference is a preference, where higher is better. Now, metrics are based on the interior gateway protocol that originates it, and there are multiple interior gateway protocols to choose from: OSPF, EIGRP, ISIS, RIP. Each interior gateway protocol has a different way of calculating its metric. A metric of 3 in RIP has a completely different meaning than a metric of 3 in OSPF. So in general, you can't compare metrics between different interior gateway protocols. Well, if you receive MEDs from different autonomous systems, each autonomous system could be running a different interior gateway protocol, and even within the different protocols, you can still adjust the metrics in different ways. So in general, a comparison of metrics, IGP metrics, between two different autonomous systems has no meaning. So because it has no meaning, by default, a MED comparison is only done between the same autonomous system. So what does that mean? The top router is a BGP neighbor with autonomous system 65002 in the middle router and the bottom router. So because the top router has two neighbor relationships, each of those neighbor relationships is with the same remote autonomous system number. So because of that, it will compare MEDs. If the bottom router was in a different autonomous system number, say autonomous system number 65003, and the middle router was in autonomous system 65002, then the top router would be a BGP neighbor with two different autonomous system numbers. And because they're two different autonomous system numbers, then a metric comparison would not have any meaning, would not be useful, and so MEDs would not, by default, be compared. There is a MED-related command called BGP always compare MED, where you can change that, where you can basically tell your router, I don't care, I want you to compare MEDs even if you get the MEDs from two different autonomous systems. Okay, so let's get into our example here. The first thing we have to do is originate our MEDs. So let's look at the middle router. Show IP BGP sum. And you can see the middle router has its neighbor with the autonomous with the top router is 172.16.2.1, and that is the 65001 autonomous system. I am autonomous system 65002 here. So let's show IP BGP sum, show IP BGP advertised routes. I'm sorry, show IP BGP neighbor advertised routes. Show IP BGP 172.16.2.1 advertised routes. Sorry, I had a little brain camp here. Show IP BGP neighbor. You put in the neighbor IP address, advertised routes, and you can see I'm advertising two routes to the top router. 172.17.0.0/16 and 172.18.0.0/16, and I'm not sending any metrics. Or it says metric 0 here. So why is that? Well, let's look at my interior gateway protocol for that route. Show IP route 172.17.0.0, 255.255.0.0, and you can see it's in my routing table, except it's a static route. And the metric is 0 because it's directly connected. So that's the metric that I'm sending. And if I do a show IP route 172.18.0.0, and I learned it via BGP, the metric is 0 because that's what I learned from the bottom router, which is originating it, which also is a static route. So you can see I'm not sending very useful information here. Let's think about what route we could send that would have an OSPF metric that would not be 0. In this case, the only route in my OSPF domain that because my network is so small here, the only route in my OSPF domain that has a non-zero metric would be the only OSPF routes that are not directly connected, 172.18.1.1. So let's take a look. Show IP route OSPF. And 172.18.2.0/24 and 172.18.1.1/32, we have metrics of 128 and 65 respectively. Conf T, router BGP 65002. Let's put in network statements to originate those routes. Network 172.18.2.0, 255.255.255. Conf T, router BGP 65002, network 172.18.1.1 mask 255.255.255.255. Now for originating a route on BGP, there are two conditions. You need to have the network statement, and you need to have an exact route that matches that in your routing table. And here's the route that matches that in the routing table. Let's do the other one just for kicks. Network 172.18.2.0 mask 255.255.255.0. Show IP BGP sum. Show IP. I mostly do that to remind me of the IP address of the neighbor. Show IP BGP neighbor 172.16.2.1 advertised routes. And here you can see I'm originating the routes with a metric of 65 and a metric of 128. Let's go to the bottom router. Show IP BGP sum. Show IP BGP neighbor 172.17.1.1 advertised routes. You can see right now I'm advertising two routes. That's the wrong neighbor. 170.17.1.1 is my iBGP neighbor. My eBGP neighbor is the one that I want to check on. So show IP BGP neighbor 172.18.2.1 advertised routes. And you can see I'm advertising two routes, 170.17.0.0 and 170.18.0.0. Metrics are 0 on both of them. And looking back at, well, let's look at my show IP route OSPF. And in OSPF, I have two routes that I can advertise. So conf T router BGP 65002 network 170.17.1.1 255.255.255. That's incorrect syntax. Conf T router BGP 65002 network 172.17.1.1 mask 255.255.255.255 and network 172.16.2.0 mask 255.255.255.0. Show IP BGP sum. Show IP BGP neighbor 172.18.2.1 advertised routes. Maybe I need to clear the neighbor. Clear, this is an older version of iOS. Clear IP BGP 172.18.2.1 soft out. I'll try that. And there we go. And so here we can see the new routes that we are advertising and the metrics. Okay, today we're talking about metrics, but one quick sanity check. What routes did I just advertise? I advertised, I am Autonomous System 65002. And the address space that I am allocated is 172.17.0.0/16 and 172.18.0.0/16. And because this was a training exercise, I went and I just advertised everything in my OSPF table. But one of the routes in my OSPF table is this link, one which is inside Autonomous System 65001's address space. And then I just went ahead and advertised it willy-nilly in a BGP. So I'm advertising, originating somebody else's address space in BGP and sending it out to the internet. That's a bad thing. You're not supposed to do that. So always in BGP, it's important to only advertise your own address space if you're an enterprise. And you don't want to accidentally become a transit provider. So always think carefully with your BGP config. Okay, but this is a training exercise, so we're moving on. And we are advertising these 4 routes, and we have metrics. So let's go see what it looks like on the top router. show IP BGP. So here's all the BGP routes. I'm on the top router, which is Autonomous System 65001. I am allocated 172.16.0.0/16, and I'm originating that. You can see the next hop is 0000, which means myself. And then I received from the bottom autonomous system 172.16.2.0/24, and I'm receiving it with a metric of 128. And that's an interesting one, because my next hop for that is the bottom router, even though I'm directly attached to it on the top router. But that's just the BGP table. If I look at the route table, show IP route, 172.16.2.0/24 is still directly connected. So I've learned the route two ways. I've learned it because I'm directly connected to it, and I learned it via BGP from another autonomous system that shouldn't be sending it to me anyway. But the administrative distance of a directly connected route is 0, and the administrative distance of an eBGP, of a route learned via eBGP, is 20, and 0 is less than 20, so the directly connected route wins. And that's as you'd expect. Directly connected is better than, if you're directly connected to the subnet, why would you route the traffic there through a different router? Just deliver it directly to the subnet. Okay. So that's the first route. The next route I'm receiving via BGP is 172.17.0.0, no metric associated with that. Actually, I'm getting it from two different ways. And one way I have a metric of 0, and one way I have no metric. And then 172.17.1.1/32, I'm learning it via the bottom router, and I'm learning it with a metric of 65. 172.18.1.1/32. Skipping down to this one, I'm learning it via the middle router, getting it with a metric. 170.18.2.0/24, I'm learning it via the middle router, and I'm getting a metric with it. So what's happening here is, because on the middle router I originated the routes that I learned via OSPF, I originated routes that were over on the bottom router, and I'm originating them with metrics. But I didn't originate them on the bottom router. And on the bottom router, I originated routes that I received received from the middle router. So my routing's sort of backwards here. My top router, if it has a packet that it's going to send to 172.17.1.1/32, it's going to send it via the bottom router. And then the bottom router will send it over to the middle router. So this is sort of weird. What's going on? Well, one of the things that's going on is that we didn't really plan out our address space advertisements very well here. What we had was fine. We were advertising two routes from the bottom autonomous system, and we're advertising one from the middle router and one from the bottom router, and it worked pretty well. Now, the internet today is at about 260,000 routes. So you don't want to advertise more routes than you need. And what we've done here is we've taken something which was nice and simple, and now we're getting 1, 2, 3. Well, this one's originating from the bottom autonomous system. We are getting 1, 2, 3, 4, 5, 6 routes where 2 did fine. So the two summarizations, 172.17.0.0, which basically is the middle router area, is good, and 172.18.0.0/16, which is the bottom router, is good. The problem is that we don't have metrics in our interior, inside OSPF for those routes. So we weren't advertising MEDs automatically. So what we really should do here is continue to advertise those address blocks, but we should influence the MEDs. So let's go ahead and do that. Looking at it right now, 172.18.0.0, we have, which is the bottom router, we have two next hops to get there, and they are similar, so we've picked this one, which is suboptimal, because 172.18.0.0 is the bottom router, and we've picked the middle router as our next hop to send it to. So let's influence our MEDs. Let's get rid of these silly specific BGP advertisements, get back to 2 BGP routes, and use and set the MEDs the way we should to have good routing. So here we are back on the middle router. Okay, let's get rid of these unnecessary network statements. And let's check what we're advertising. Show IP BGP neighbor 172.16.2.1 advertise. And we're down to only 2 route advertisements once I remove the network statement, so I don't need to do a clear IP BGP here. And let's create a route map. IP prefix list set med match permit .17.0.0/16 and IP prefix list. Let's come up with a better name here. From bottom permit 172.18.0.0/16. No IP prefix list set med. IP prefix list from middle permit 170.17.0.0/16. So IP route map set med. IP route actually it's route map set med permit 10 match. Okay, so what we've done here is we've created 2 prefix lists. One is from bottom, which is the route which originates in the bottom router, and one which is from middle, which is the route that originates in the middle router. And what I want to do is I want to set the metric on the from middle to be small, and I want to set the metric or the med on the route from the bottom router to be high. And I'll do the converse on the bottom router, and that way the top router will have intelligent routing information to choose where to send the traffic. Okay, so route map set med permit 10 match from middle match IP pre match IP address prefix list from middle. So let's set a low metric. Set metric 1. And then we're in our route map stanza here, so route map set med permit 20 match IP address prefix list from bottom set metric 20. So in our route map, we've done two things. We've matched the route from the middle and set a metric of 1, and we've matched the routes from the bottom, and we set metric 20, but we also did something else. We implicitly denied everything else. Because a route map, in each stanza, you do a match, and then you do some sets. But at the end, if you don't, anything you don't match is implicitly denied. So let's do an implicit permit just so we don't change the current behavior. Route map set med permit 30. And here I'm not going to have any matches, I'm not going to have any sets, I'm done. Okay. So show route map. So here's my route map. Route map set med. All the lines are permits. Sequence 10, so it's the first one in the sequence. We match routes which match the from middle prefix list, and we set a metric of 1, which is very low. And then route map set med permit 20, we match IP addresses that match the prefix list from bottom, and we set a higher metric of 20. And then we want everything else, all other routes, to just not be affected at all. So route map set med permit sequence 30, and we leave a blank match so it matches everything, and we leave a blank set so it doesn't set anything, but it's permitted. So show run pipe begin router BGP. Okay. Conf T router BGP 65002 neighbor 172.16.2.1 route map set med, and I can apply it to inbound routes or outbound routes. I want to affect the outbound routes here, so out. Show IP BGP neighbor 172.16.2.1 advertised, and you can see nothing has changed with the metrics. Let's clear IP BGP 172.16.2.1 soft out and do it again. Didn't do anything. Let's clear IP BGP 172.16.2.1. Do a hard clear. I'll pause for a minute here. Okay, so here's something that's always sort of bothered me. So I do my show IP BGP sum. I have my neighbors. Show IP BGP neighbor 172.16.2.1 advertised routes. And you can see here are my two routes, and it appears that the metric is not set on the routes. Now let's go to the top router and see what the top router thinks. Show IP BGP. So here, you can see here's the 170.17.0.0, and when I get it from the middle router, the metric is set to 1. And then here's the 170.18.0.0, and when I get it from the middle router, the metric is set to 20. So you can see that I did set the route successfully, but I couldn't see it on the middle router, which is the router that I control. I could only see it on the top router, which is the router that somebody else controls in a different autonomous system. And this, I don't know if this is correct behavior or not. I don't know if this is a bug that has been fixed in a more recent version of iOS, because again, I'm running on some old routers here, but it's just disturbing. It'd be nice to be able to see what the metric is when I advertise it. But my configuration is correct. Now let's look at the impact of the configuration. the best way to see the impact, well, here, 170.17.0.0, we have two next hops, the middle router and the bottom router. The middle router is a metric of 1, and the bottom router has no metric set at all. So which one did it choose? It chose the bottom router. Because by default, with these versions of iOS, if a metric is not set, it's treated as a 0. Now there's a command to adjust that, and that command is BGP best path med missing -as -worst, which means that if when you're comparing meds, if the med is missing, you assume that's the worst possible med. So let's go ahead and configure that. Conf T router BGP 65001 BGP best path BGP best path med missing -as -worst. Show IP BGP. And now you can see that the med was 0, and so because of the BGP best path med missing -as -worst, it assumes that the path that did not have the med said med is now set to some huge number. And in fact, I think there's a recent BGP RFC which says that this is correct behavior, that in the future, if you don't receive a metric, you should treat it as the worst, and you should prefer any metric that is set over no metric being set. Okay, so back to the point, 170.17.0.0, and now the metric of 1 is better than the no metric at all, which, thanks to our BGP best path med missing -as -worst, is now the worst possible metric that can be set. Meanwhile, on the other side, 170.18.0.0, we're receiving it with a metric of 20 from the middle router, and it's being originated by the bottom router, and the bottom router has a null static route, so it has it directly connected, and so it the bottom router actually set a metric of 0, which is actually a reasonable value. So what we're doing here is, for 170.17.0.0, we're sending it to the middle router thanks to our med. And for 170.18.0.0, we're sending it to the bottom router thanks to our med. So we're doing what is optimal behavior. 170.17.0.0 should go to the middle router, and 170.18.0.0 should go to the bottom router. So success. We have accomplished what we wanted to do. And let's again look at how we accomplished that. Show run pipe begin router BGP. We set so we used the route map to set our med, and the route map used a prefix list, 2 prefix lists. For the routes we wanted to originate from the bottom router, or we wanted a low metric on, we have a prefix list from bottom, and it has one line which matches exactly 172.18.0.0/16, and only that route. And we have a prefix list from middle, which matches 172.17.0.0/16. And then we set up a route map with 3 stanzas. In the first stanza, we match the from middle route, and we set a metric of 1. And in the bottom, in the second stanza, we matched the from bottom route, and we set a metric of 20. And then in the third stanza, we matched everything, and we set nothing. So that's just we don't have any routes which use the third stanza right now, but it's safer to not change behavior, and by putting that in there, we did not change behavior. Now, just for an experiment, let's take out this route map and leave that BGP best that BGP best path med missing AS worst command in there. Conf T router BGP 65002 no neighbor 170.16.2.1 route map set med out. When doing a command like that, it's important not to accidentally hit return after the no neighbor and then the IP address, because that'll blow away the whole neighbor config. You want to type no neighbor, the IP address, and the full command that you want to remove. Only blow away the neighbor if you want to blow away the neighbor. Now, if you accidentally blew away the neighbor, you could do a show start. If you accidentally blew away the neighbor and you haven't done a write mem yet, you can do a show start and see the old config. That's useful. Okay, let's clear my BGP configuration. Clear IP BGP neighbor 172.16.2.1 soft out. Clear IP BGP 172.16.2.1 soft out. And let's go to the top router and see what effect that had. So this is pretty cool. We've successfully eliminated those metrics. And actually I've still got some old routes from the other ones. So let's clean that up too. So here I am on the bottom router. And I want to clean up the network statements. Conf T router BGP 65002 no network 172.16.2.0 with the mask, no network 172.17.1.1 with the mask, and then clear IP BGP 172.18.2.1 soft out. Show IP BGP, and looks like clear didn't take effect because that neighbor is a old iOS. So let's do a hard clear. Clear IP BGP 172.18.2.2, and I'll pause for a second. Okay, my neighbor's back up. I do a show IP BGP. I have 3 routes, and for 170.17.0.0, the router on the middle router is directly connected to it because it has a static route, so it has it's actually sending me a metric of 0, whereas the bottom router is not directly connected to it, so it does not send a med, and because of the BGP best path med missing -as worst command, we set the worst possible metric on it. So for 170.17.0.0, we prefer the middle router, which is correct, because the middle router is where that route is actually originating. Meanwhile, on 170.18.0.0, the bottom router is originating the route, and it has the static route, so it sends us a metric of 0. And the middle router is not sending us a metric, and so we set the metric to the worst possible. So we are preferring the bottom router. This is pretty cool. The BGP best math med missing -as worst is now the only configuration difference between when we started today's lesson and when we ended today's lesson. And just by executing that command, which is now recommended as a best practice, so perhaps that means it should be in our standard config, our routing is working in an ideal fashion. So that concludes our lesson today on MEDs, multi-exit discriminators. To review real quick, a MED is a way to inject a routing protocol information from your interior gateway protocol in your BGP advertisements. And then your BGP neighbor in a different autonomous system can choose which path to take to get that traffic into your autonomous system based on the optimal routing information from your autonomous system. However, by default, a MED, which a BGP advertisement that does not include a MED is by default in Cisco IOS treated as a MED of 0. However, with the BGP best path MED missing-AS worst command, we can eliminate that behavior and giving us better routing in a default fashion. The other important thing to remember is that MED is based on is the Multi Exit Discriminator. It's based on metrics from the interior gateway protocol. Interior gateway protocols, different interior gateway protocols and different autonomous systems can have different metrics and different ways that metrics are calculated. So by default, you cannot and should not compare metrics between different autonomous systems. If you decide that you want to for some reason, then you would use the BGP always-compare-med command to do that. Okay, that concludes today's session. Thank you.